Students, now we are in the topic of mean value theorem. Among the topic we have completed level 1 classwork and level 2 classwork also. Let us discuss about level 3 today. In this topic, in previous class I said the concept, definition of formula and everything. Later we completed level 1 classwork, level 2 classwork also. So many times I said that level 1 classwork, level 2 classwork, level 3, level 4 also I will handle. I will send pics level 1 homework and level 2 homework. This is very important topic. That is why I am not losing any question. So try to understand, students, and every sum you do. Let us discuss about first question in level 3. Let f of x is continuous function on closed interval a comma b and differentiable function on open interval a comma b. He given f of x not equal to 0 for all x belongs to a b, then there exists theta belongs to open interval a comma b. So a small value theta belongs to open interval a comma b whenever it is continuous and differentiable on closed interval a comma b and open interval a comma b respectively, then such that f dash of, so you should calculate the value such that f dash of theta by f of theta. Options given in the form of 1 by a plus theta, 1 by b minus theta, like that. Every option related with a and b. So let the function also related with a and b. Let us take the function phi of x is equal to a minus x into b minus x into f of x. Because f dash of theta and f of theta related function is there. This is another, f of x should be here. If we take f of x, f should not get here. So phi of x, this is another function, a minus x into b minus x into f of x. Let us, according to Rolle's theorem or Lagrange's theorem, f of x continuously differentiable he given such that he given f dash theta by f of theta we should calculate. Okay, let us try Rolle's theorem. Phi dash x I am doing. This is u v w derivative u dash v w plus u v dash w plus u v w dash. This one derivative minus 1 into b minus x into f of x plus this derivative here a minus x into here minus 1 into f of x plus here a minus x into b minus x into f dash x. This is equal to 0. That implies we can write here f of x, phi dash of theta I am writing. Okay, let us discuss about this one. F dash x into a minus x into b minus x is equal to this term taken this outside, taken that side. We can write here minus taken that side, minus taken that side. B minus x plus a minus x. So f dash x is equal to, according to this one, f dash b minus x, f of theta minus a minus x is there. Let us write here. Let us write properly. That implies I am writing minus b plus x into f of x minus a plus x f of x and right here plus f of x into, you write minus a plus x is equal to f dash x into a minus x into b minus x. So that implies f of x taken common, don't write is equal here, plus only. F of x taken common, then you can write here x minus b plus x minus a, same method we got, plus f dash x into a minus x into b minus x. F dash x by, let us write f dash theta by f of theta. So we can write here f of x into 2x minus of a plus b is equal to minus of f dash x into a minus x into b minus x. Let us notate theta f dash theta by f dash theta, f of theta, f dash theta by f of theta, taken this side, 2x by 2x minus a minus b by a minus x into b minus x, a minus x into b minus x. Maybe he taken like this, minus is there, 2x by a minus x into b minus x. So theta, while we are writing theta, we should write theta only. So let us try to understand here f dash theta by f of theta. Instead of x, you write theta, f of x in denominator f dash theta. Here you write a minus theta, a minus theta into b minus theta in denominator, this one, a minus theta into b minus theta, this is along with the minus. Here 2x minus, this one only you can write, no need to write 2x like that, x minus a, x means here theta, theta minus b, theta minus b plus theta minus a I am writing, theta minus b plus theta minus a, this is b minus theta. That implies we can write here f dash theta by f of theta is equal to theta minus b whole by, we can write denominator theta minus b into theta minus a, taken minus common, plus write here theta minus a by theta minus b into theta minus a. Theta minus a get cancelled, theta minus b get cancelled. Therefore, we can write using Rolle's theorem f dash theta by f of theta. F dash theta by f of theta is equal to 1 by theta minus a plus 1 by theta minus b. Let us see the option. 1 by a minus theta plus 1 by b minus theta he given. 1 by a minus theta plus 1 by b minus theta. Maybe the value f dash theta by f of theta minus b plus x. You do one thing. Let you try. Whether it is mistake, you find, students. Using the same thing you can calculate. Y dash x is equal to 0. Next, let us discuss about second sum. Let f of x be differentiable function. Let f of x be differentiable function. Beta minus everything is okay. You find whether it is mistake, you inform me, students. Second question, let f of x be twice a differentiable function for real x such that f of 1 equal to 1, f of 2 equal to 4, f of 3 equal to 9, f of 1 equal to 1, f of 2 equal to 4, f of 3 equal to 9. Then which are the following statement? Definitely true. Directly we can understand that 1 square equal to 1, 2 square equal to 4, 3 square equal to 9. Therefore, you can say that f of x equal to x square. Therefore, f dash x is equal to 2x is there, and f double dash x is equal to 2. F double dash x is equal to 2 on 1 comma 3 because this is 1 square and this is 3 square. That's all. According to options, first option is correct. Next, let us discuss about third question. In closed interval 0 comma pi, Rolle's theorem is not applicable. Using options, we should calculate which is possible, which is not possible. In 0 comma pi, f of, according to Rolle's theorem, f of a is equal to f of b. So f is continuous and f is differentiable. Sin x is a continuous curve and sin x is differentiable. And next, so first option is okay. Cos x is also differentiable. Third option okay. Sin square x plus sin x, it is also okay. So let us discuss about second option. In 0 comma pi, which is not applicable, is asking. F option 2 I am discussing. F of x is given as sin x by x. Sin x by x, x not equal to 0 and it is 1 sin x is equal to, whenever x is equal to 0. It is 1 when x equal to 0. Therefore, you can try to understand that limit x tends to 0. Limit x tends to 0, sin x by x is equal to 1. So you know that 1 given. Therefore, f is continuous. Until here it is okay. F is continuous, okay, limit exists, okay. But let us discuss about the value f of 0. This is called as f of 0. F of 0 value whenever x equal to 0. F of 0 is equal to 1 he given. Now, f of 0 is equal to 1 we got. What about thinking f of pi? Then you can try to understand that limit x tends to pi, sin pi by pi. You know that the value of sin pi, here limit, there is no question of limit. Directly you can substitute. So f of pi directly substitute. Whenever a direct substitution, sin pi by pi, sin pi equal to 0, 0 by pi, 0 by pi equal to 0, so 0 not equal to 1. Therefore, f of 0 not equal to f of pi. Therefore, Rolle's theorem not holds. Rolle's theorem does not hold. Rolle's theorem does not hold. Second option here. Next, let us discuss fourth question. Let f of x be non-constant differentiable function. Non-constant. So, whenever it is constant, the derivative is 0. So, whenever it is 0, there is no question of calculating about the function, Rolle's theorem conditions. That is why he given the condition f of x is non-constant differentiable function for all real x and f of x equal to f of 1 minus x. Given condition I am taking. Given condition. He given that the condition is f of x is equal to f of 1 minus x. Then the Rolle's theorem is not applicable for verification of options I am saying. According to options. According to options, verification of options. First option he given 0, 1. So substitute the value 0 here. F of 0 is equal to f of 1. That's all. Okay. Next. F of 0 is equal to f of 1 we got. Next. Second option. Minus 1, 2. So f of minus 1 you substitute here. F of 1 minus 2. F of 1 minus 2 is f of minus 1. So f of 0 is equal to f of 1 minus 0. F of 0 is equal to f of 1 he got. F of x is non-constant, it's okay. Next, let us discuss about f of minus 1 equal to f of minus 1. Both are same. Next, third one. Third option, minus 2, 3. Minus 2, 3 meaning f of minus 2 substitute is equal to f of 1 minus 3, f of minus 2. So value we are getting, everything is same. But fourth option, maybe this one. Fourth option, f of 0. Fourth option given as 0, 2 by 3. The value f of 0 is equal to f of 1 minus 2 by 3. F of 0 is equal to f of 1 by 3. Here we got f of 0 is equal to f of 1. F of 0 is equal to f of 1 by 3. So it is not possible according to 1 minus x. So option 4 is correct option. Option 4 is correct. These are this okay. F of 0 is equal to f of 1 means he should give like this. F of x is non-constant differential function for all real x. F of x equal to f of 1 minus x. Then Rolle's theorem not applicable he given. Just maybe should give according to first option also f of 0 is equal to f of 1. He should give the value in 0, 1, then it is okay. Otherwise first and fourth option. According to options, fourth option he given f of 0, whenever f of 0 is equal to f of 1, f of 0 is equal to f of 1 by 3, then f of 1 by 3 is equal to f of 1 should be there. Such thing is not possible. According to these, f of 1 is equal to f of 1 minus x equal to f of x. So option 4 is right. Fifth question. The real number case. This is important question. This is multi-conceptual question. The the real number k for which the equation 2x cube plus 3x plus k is equal to 0 has two distinct real roots. Let us discuss about a formula. Before discussing the sum formula, if ax square plus bx plus c comma, this is a quadratic equation. You will be learning proof of this theorem in second year quadratic equation. Ax square plus bx plus c comma a have same sign. Ax square plus bx plus c comma a have same sign when delta less than 0. Same sign. When delta less than 0, for all x belongs to R. That is, function f of x has delta less than 0, meaning f of x has imaginary roots. Imaginary roots. That is, no real root I am saying. No real root. Whenever delta less than 0 for all x belongs to R, the function f of x means this is the function quadratic equation has no real roots. Whenever ax square plus bx plus c having same sign, meaning the full function x square plus bx plus c positive and a is positive, meaning coef of x square. Or the full function ax square plus bx plus c is negative and here it is negative. Maybe here minus x square plus bx plus c we had written, then total function less than 0. Here 1x square or 2x square, 3x square, anything, 3x square plus bx plus c greater than 0, then here 1, 2, 3, everything number is positive. The coef of x square function should have same sign. When they have same sign, then the formula delta less than 0 is rule, formula, sure. Then meaning f of x has no real root. Depends upon this one. Let us consider about fifth question. The real number k for which equation, given equation, he given the cubic equation, given equation 2x cube, given equation 2x cube, cubic equation given equation 2x cube plus 3x plus k, 2x cube plus 3x plus k equal to 0 has two distinct real roots. He is saying that the cubic equation has two distinct real roots. In 0, 1, I am writing here, the cubic equation has two distinct real roots. Two distinct real roots in closed interval 0, 1. Then, according to options, what is then? The real number k we should calculate. What is the value of real number k? To calculate the value of real number k, let us discuss about according to rules theorem f dash x. F dash x is equal to, this is 6x square. 6x square plus 6, that's all. Whenever you take common 6 into here, x square plus 1, we know that every square is positive. Every square greater than 0, greater than or equal to 0, but here 6x square plus 1 is there, positive plus 1 into positive. So you can say that 6x square plus 6 greater than 0. Here I am discussing about this formula and this one. Ax square plus bx plus c and a have same sign. Here I am writing the value here, a is equal to 6. And ax square plus bx, a is equal to 6, so a greater than 0 and 6x square plus 6, that is the according to square, this is positive. Now you can calculate delta. Delta here b square minus 4ac, 0 minus 4 into 6 into 6. 100% you will be getting negative. Therefore, here f dash x has no real roots. F dash x has no real roots. Whenever f dash x means it is a quadratic polynomial. This is a cubic polynomial. Cubic polynomial reduced as quadratic polynomial. Whenever quadratic polynomial has no real roots, there we can say that the two roots are distinct or anything imaginary roots. There is no real root. But he given as the question has two distinct real roots. It is absolutely wrong. So whenever it is wrong, there is no existence of k. It is absolutely wrong. Therefore, conclusion, we can say that k has no value. In real, that's all. K has no value in real. According to option, he given that options 4 does not exist. It is correct. It is important, students, because it is multi-constituent question, depends upon quadratic expressions. Next one. Sixth question. If f is a continuous function on 0, 1, closed interval 0, 1, f is a continuous function and differentiable in open interval 0, 1. In this question is discussing about 0, 1, closed and open. F is continuous on closed interval 0, 1 and differentiable on 0, 1 such that f of 1 is equal to 0. F of 1 is equal to 0. This is given value. And then there exists a small c belongs to open interval 0, 1 such that according to option we should calculate. Every option is, students, every option is merged with fc with c, fc with c, otherwise f dash c with c. Whenever we take uv, a function in the method of uv, then formula uv dash plus v dash. Whenever we take the formula u by v, the formula derivative u by in the form of u by v, vu dash minus u dash by v square. Vu dash minus u dash by v square. Maybe options, 4 options are there in the method. Let us discuss about, let the function g of x is equal to x into f of x. Just let us know. F be a continuous function, the function depends upon z. He is asking the f be a continuous function on 0, 1, differentiable on 0, 1, everything okay, such that f of 1 is equal to 0, okay, such that c belongs to 0, 1. Whenever if we take differentiating both sides, differentiating both sides, g dash x is equal to x into f dash x plus f of x into 1 equal to 0. Let us discuss g dash c is equal to, now g dash c I am writing, g dash c is equal to c into f dash c plus f of c equal to 0. We got the fourth option. So f of 1 is equal to 0. Why we have to just let us verify the option number. Sixth question he given as fourth option. Now why we have taken like this? Let us verify. F of 1 0 he given. Let us think 0, g of 0. Yes, g of 0 is equal to 0 because substitute 0. Next g of 1 you take. G of 1 means 1 into f of 1. So g of 1 is equal to, what is the value of f of 1 he given? F of 1 value 0. That applies. Therefore, you can say here g of 0 is equal to g of 1. First you write this. Later you can confirm that g of x, yes, g of x into x into f of x is right. Whenever g of x into x into f of x, then you can calculate the derivative. It is correct. Option 4. So according to given f of 1 0, we have written like this. Next let us discuss about seventh question. Seventh question, a, b, c are real numbers such that given condition a, b, c, d are real numbers. 3a plus 2b, 3a plus 2b by c plus d plus 3 by 2, 3a plus 2b by c plus d plus 3 by 2 equal to 0. Then the equation has, equation which one? Equation ax cube plus bx square, ax cube plus bx square plus cx plus d equal to 0 has been asked. By verifying options we can get at least one root, at least two roots is given. At least two roots is not correct way, no root is not correct way, maybe the options 1 and 2. So let us think this one. By taking LCM we get 6a plus 4b plus 3c plus 3d equal to 0. You can write. Let it be first equation. Now In previous question, level 2, we discussed that whenever the equation has is asking, this is nothing but derivative. Because by Rolle's theorem we conclude that f dash, whenever f dash is equal to 0, then there exists a small c belongs to open interval a comma b, such that there exists minimum at least one value. So let, I am writing here, let f dash x is equal to here. Let f dash x is equal to ax cube plus bx square plus cx plus d equal to 0. Integrating both sides, I am writing. Integrating both sides. Integrating both sides, we can get the integration of ax cube, ax power 4 by 4. Power 4 is there. Ax power 4 by 4. Ax power 4 by 4 plus this one bx cube by 3. Bx cube by 3 plus cx square by 2 plus dx equal to 0. Some constant e by condition. If the given value, according to given value, let us verify. E given that, such that simply this one only given has, let us verify for every option 0 is there. Let us write f of 0. This is f of x, students. This is f of x. F of 0 becomes 0. So 0 is equal to e, constant becomes 0. Then f of x, you conclude that ax power 4 by 4, this one totally, ax power 4 by 4 plus bx cube by 3 plus cx square by 2 plus dx. This is f of x we got. Now, if we substitute the value to get 6a plus 4b plus 3c plus 3d, if we substitute the value 3 may be 3 power 4 like that. If according to option 2 is there. So let us discuss about 2. According to option f of 0 we conclude, decided f of 2 let us substitute. 2 power 4, 16. 2 power 4, 16. 16 by 4, 4. 4a. Next, this is 4a plus 8 by 3. Okay. 4a plus 8 by 3b plus 2 square by 2. This is 2c plus 2d equal to 0. Let us consider this is by taking LCM 12a plus 8b plus 6c plus 6d equal to 0. If we divide by 2, we can take here 6a plus 4b plus 3c plus 3d equal to 0. From 1 it is true, I am writing. From 1 it is true. What is true, sir? F of 2 is equal to 0 is true, comma, f of 0 is equal to 0. Therefore, there exists a value between 0 comma 2 closure interval according to option 2. There exists a value between 0 comma 2. We completed 7 questions. Let us discuss 8th question. Before we discuss 8th question, let us discuss about the concept of Descartes rule, which can be learning, which you may learn the concept Descartes rule in theory of equations after in 2a. René Descartes invented the concept Descartes rule, I am saying. Descartes rule. Descartes rule. So, what is the Descartes rule meaning? Descartes rule. If f of x is an nth degree polynomial, if f of x is an nth degree polynomial. Let us take f of x is equal to x power n plus a naught x power n, nth degree polynomial notation. You can say that a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus 1 a1 x plus a naught 1 2 3 so on. So this is an minus 1 into x plus an. Number of changes of sign in f of x. Number of changes of sign in f of x is equal to number of positive roots. Number of changes of sign f of x equal to number of positive roots. Next, number of changes of sign in f of minus x is equal to number of negative roots. Next, number of changes of sign in f of x comma f of minus x. I mean this is end. Both number of changes of sign in f of x and f of minus x is equal to number of positive plus negative. Positive plus negative, you can say that number of real roots. Number of real roots. Next, number of imaginary roots I am saying now. Number of imaginary or complex roots. Number of imaginary roots is equal to n minus. What is the n means? The nth degree polynomial. n minus real roots. Number of real roots. n minus number of real roots is equal to number of imaginary roots. Let us consider an example. Let f of x is equal to a small example I am taking to try to get understand. X cube minus 6x square plus 6x minus 6. It is f of x. Number of changes I am saying. Number of changes in f of x is equal to the change in symbol. Number of changes of sign is first this is plus. According to coef of x cube I am saying. Coef of x cube plus 1. There is no question of whether it is 1 or 6 or 7 or quotient, no need. You observe the symbol. This is a plus. That plus became in next as a minus. So, and the minus became as a plus and plus became as minus. Total how many changes are there? This is 1, this is 1, this is 1. Plus to minus, it is a change. Minus to plus, it is a change. Again plus to minus, it is a change. So, number of changes in f of x equal to 3. Therefore, number of positive roots equal to 3. Next, now let us consider f of minus x. You substitute the value minus x instead of x. It becomes minus x square. Minus x whole square becomes minus 6 only. This is minus 6 minus 6. So now you observe number of changes. Number of changes in sign I am discussing. Number of changes means number of changes in sign. Number of changes in sign. So plus becomes minus, it is change. Minus becomes plus, it is change. Minus, not change. Minus simply as it is became minus. So there is no change. Minus again no change. Again no change. Therefore no change. Number of changes equal to 0. Number of negative roots. Now you can say that negative roots equal to 0. Therefore total roots, total real roots equal to 3 plus 0, that is equal to 3. So the function completely having positive roots. Now about imaginary roots are complex roots. About imaginary roots, what I said, the total degree here, degree of the polynomial is highest number, highest index 3. Now you can write 3 minus 3 because 3 for real roots. 3 minus 3 equal to 0. imaginary roots are 0. Small example I said, depends upon this one, Rene Descartes rule. Let us discuss about next sum. The question, now the question number 8, that f of x is equal to 1, 1, 1, determinant he given. 1, 1, 1, 3 minus x, 5 minus 3x square, everything we should write. 8th one. F of x is equal to, draw the determinant. 1, 1, 1, 3 minus x, 5 minus 3x square, 3x cube minus 1, 2x square minus 1, 2x square minus 1, 3x power 5 minus 1, 7x power 8 minus 1, this one. Then the equation according to options also. No real root, at most one real root, at least two real roots, exactly one real root, in 0, 1 and no other real. Let us discuss about f of x equal to 0 only he given. Put, students, put x equal to 0 you write. X equal to 0. Therefore f of 0 is equal to 1, 1, 1, 3, 5, 3, 2, 3, no, this is minus 1. 3, 5, 3, minus 1, minus 1, minus 1. Here rows are identical. Whenever rows are identical, that is 0. F of 0 is equal to 1. Next, f of 1, let us substitute. 1, x is equal to 1. Put x is equal to 1. 1, 1, 1. This is 3 minus 1, 2. This is 5 minus 3, 2. This is 3 minus 1, 2. This is 2 minus 1, 1. 3 minus 1, 2. And 7 minus 1, 6. Here 1, 1, 1, 2, 2, 2. Rows are identical. That is 0. Therefore, we confirm that f of 0 is equal to f of 1. So, Rolle's theorem may applicable. Sure. F of x. He said that, then the equation simply he said f of 0 is equal to f of 1. We know that students in the matrix derivative, first we should calculate row 1 differentiation, row 2, row 3 common, row 2 differentiation, row 1, row 3 common, row 1, row 3 common, row 1, row 2 common, row 3 differentiation, like that is there. So, by calculating f dash c, we should use the derivative of matrix. The derivative of matrix. So now let us discuss about the function 1 1 1 1 1 1 derivative of, don't forget to calculate the derivative of a matrix. First we should calculate row of first derivative of first 0 0 0. So no need to write, I am writing row 2 row 3 because the row becomes, that becomes 0, R2 R3 plus. Next, row 1 keeping fixed. Now derivative of second row, minus 1 minus 6x. 3 3s are 9x square. 9x square. This one 9x square. And this is keeping fixed. 2x square minus 1. 3x power 5 minus 1. 7x power 8 minus 1. 7x power 8 minus 1. Next, let us discuss about derivative of third row, keeping first, second fixed. Here 3 minus x. Now 5 minus 3x square. 3x cube minus 1. Derivative of third row 4x. This can be written as 15x power 4 and this can be written as 56x power 7. Students, try to understand that if you multiply, it becomes minimum here 1 into 6, x into 7, x into x power 8. It may x power 9. So we can say that this is 9th degree polynomial. 9 into 7 here, this is 9. So this is you can say f of x is ninth degree polynomial. F of x is ninth degree polynomial. Ninth degree polynomial we got. Whenever ninth degree polynomial is there, we may, according to Descartes rule, by Descartes rule, previously we discussed it. By Descartes rule, we can say that f of 0 is equal to f of 1 already. We substituted x, for x also we can substitute 0, 1 roots are there. Other than 0, 1, maybe any one root may be there. Then we can say that there exist at least 2 real roots. At least 2 real roots exist for the f of x value. At least 2 real roots, that's all. Maybe or may not be, maybe 7 roots are real or 8 roots are real, anything, because this is ninth degree polynomial. While if you need full, you find the determinant, and full you find the number of changes in sign of f of x and number of changes in sign of f of minus x by Descartes rule, you will be getting the roots are whether real or imaginary, or how many real roots are there, how many positive roots are there, how many negative roots are also, you can get by completion of determinant. Simply I said during this one ninth degree polynomial. According to ninth degree polynomial I said. Next let us discuss about ninth question. Let us discuss about ninth question. Ninth question, consider the function f of x is equal to 8x square. 8x square minus 7x plus 5. 8x square minus 7x plus 5 on the interval minus 6 comma 6. Then the value of c that satisfies the conclusion of Lagrange's mean value theorem. So simple question only. Using the formula f dash c is equal to f of b minus f of a whole by b minus a. Simple question. Now you can say f dash c. What is f dash c? 16c. 16c minus 7 is equal to, now let us substitute the value 8 into 6 square, 8 into 36 minus 7 into 6, 42 plus 5. This is for f of b minus f of a. 8 into this one also 36. 8 into 36 plus this is 42. 7 6 are, this is 42 plus 5 whole by f of b minus f of a. This is 12. So we can say here 8 into 36. The value 8 into 36 is 288. 8 6 are 48, 4 8 is 288. 288 minus 42 plus 5 minus this one also 288. 288, this is minus 42 minus 5 whole by 12. 288 will be getting cancelled. 5 getting cancelled. Minus 42 becomes minus 84. 16c minus 7 is equal to minus 84 by 12 gives minus 7. Then 16c is equal to 14. C is equal to 7 by 8. C is equal to 14 by 16, 7 by 8 we got. Ninth question. The conclusion, the value theorem. Consider the function on the interval, then the value of c is that satisfies conclusion Lagrange 0 he got. Maybe this is not 8x square 60. 8x square minus 7x on minus 6 comma 6. It's okay. Plus 5. This is derivative 16c minus 7. 8 into 6 square minus 7 into 6 plus 5 minus 8 into minus 6 whole square 36 minus 6 plus 42 plus 5 288 days minus 42 plus 5 minus 288 minus 42 minus 5. This is minus 7. 16c is equal to Now we got the value 16c is equal to 14. By Lagrange's mean value theorem, consider the function on the interval minus 6 comma 6. Then the value set is, we got the value 7 by 8. According to option, let us verify. Ninth question, he given first option. Here I done mistake. 8 into 36 minus 7 into 6 plus 5 minus 8 into 36 plus 7 into 6 plus 5 is equal to minus 7. 16c minus 7. No, it is wrong. You verify, students. We got correct answer. 10th question. 10th question, using Lagrange's mean value theorem, f of x is equal to cos x. Using Lagrange's mean value theorem, f of x is equal to cos x, we get that modulus of cos a. Modulus of cos a minus cos b less than or equal to dash. So, formula, let us write the formula. F dash c. F dash c is equal to LMVT. I am writing Lagrange's mean value theorem. F dash c is equal to f of b minus f of a whole by b minus a. F of b minus f of a by b minus a. Now, what is the derivative of cos x? Sin x. We can write here minus sin c. Minus sin c is equal to, write the formula cos b. Cos b minus cos a whole by b minus a. That implies, take a minus common both sides, it becomes cos a minus cos b. According to modulus, he is saying, by taking modulus you can say a minus b also, or b minus a. Mod you put it is better. We know that, I am writing, we know that the maximum value of sin theta is less than or equal to 1. Maximum value of sin theta 1. The value of sin theta less than or equal to 1. Then we can say modulus of cos a minus cos b by modulus of a minus b less than or equal to 1. Therefore, modulus of cos a minus cos b lesser than or equal to modulus of a minus b. If option given as modulus of b minus a also, you can write. Now it is second option. Completed 10 questions. Let us discuss about 11th question. F maps 0 comma 4. Here closed interval 0 comma 4 given to the value, real number. F maps 0 comma 4. F maps 0 comma 4 to real number, be differentiable function. There exists alpha comma beta in the open interval 0 comma 2 such that in the open interval 0 comma 2 such that integral 0 to 4 f of t. 11th question. F maps closed interval 0 comma 4 to real number given value. Closed interval 0 comma 4 to this one. Alpha, beta, there exists alpha and beta in the open interval 0 comma 2. Two roots are there. Roots I am writing. Two roots. Roots alpha comma beta in open interval 0 comma 2. Open interval 0 comma 2. Such that he is discussing the condition as integral 0 comma 0 to 4 f of t dt. Integral 0 to 4 f of t dt. Let us discuss about Leibniz theorem here. Already I said with you in the topic tangents and normals. Leibniz theorem. What is the Leibniz theorem? Integration, relation of derivative and numerical integration. D by dx of integral d by dx of integral phi of x to psi of x f of x dx is equal to f of psi of x. F of psi of x into d by dx of psi of x minus f of phi of x into d by dx of phi of x. d dy dx of phi of x. This is the Leibniz theorem. It will be useful for us now. Now I am writing integral 0 to 2 he given, here integral 0 to 4 he given, and the value he given as 0 comma 2. Let us try to understand that 0 square is 0 and 2 square is 4. So you can take, let here capital F of x I am writing. Capital F of x is equal to integral 0 to x square f of t dt. Yes, in the morning. Capital F of x will integral 0 to x square f of t dt. So that implies f dash x, you can write here. I said that Leibniz theorem, whenever we are differentiating both sides, f dash t means here diff both sides. Whenever differentiating both sides, you can write integral phi of d by dx of phi of x to psi of x. Integral f of x dx is f of psi of x into d by dx of psi of x minus f of phi of x into d by dx of phi of x. You should try to understand that you write here f of x square. So whatever the value is there, you will substitute f of x square, f of small f of x square into internal derivative is the meaning of d by dx of psi of x, 2x minus f of 0 into internal derivative of 0 becomes 0. That is why no need to write. Therefore f dash x we got as f capital F dash x. Capital F dash x we got as f of x square. You can write here f dash x is equal to f of x square is a polynomial we got. Now let us see the some question. F of x, f dash x we got f 2x also. F of x square into 2x also. Now you are able to understand, you can able to understand that according to options, so 2 should be there, alpha and beta, 2 roots are given, alpha should be there and beta should be there, 2 alpha f of alpha square and 2 beta f of beta square. According to option it is 4th option. Now otherwise you can say let f dash x is equal to f of x square into 2x. And let us consider according to fundamental theorem of integral calculus. For I am saying, for integral 0 to 1 f of t dt. Okay. For integral 0 to 1 f of t dt is equal to f of 1 minus f of 0. F of for I am writing next one. This is 1 square, students. Integral 0 to 2 not integral. This is 1 to 2 square. Integral 1 to 2 square f of t dt. 1 to 2 square f of t dt, you can write here f of 4, f of fundamental theorem of integral calculus, f of 2 minus f of 1, f of 2 minus f of 1. By derivating, by deriving I am writing, by Rolle's theorem f dash c is equal to, otherwise phi dash c is equal to this one, f of b, this one. So this is 0, this is 0, you can say here f of 1 is equal to f of 0 is equal to f of 2. So everything okay, the values. F of 1 is equal to f of 2 and f of 0 is equal to f of 1. Rolle's theorem holds. Whenever Rolle's theorem holds, you can say that it is derivable, it's already derivative exists. Then integral 0 to 1 he is discussing roots alpha in 0 comma 2. Then let you can write alpha belongs to 0 comma 1 and beta belongs to 1 comma 2. Alpha belongs to 0 because distinct roots are there for the given function. So now you can say that f of x is equal to, directly you can write f dash x is equal to. If you understand, no need to write this one, here only you can conclude here. F dash x is equal to f dash x into 2x. For alpha and beta I am writing. So integral one step I am writing here. 0 to 4 f of t dt is equal to integral 0 to 1 square f of t dt. Integral 0 to 1 square f of t dt plus integral 1 square to 2 square I am writing. 1 square to 2 square f of t dt. Previously I said the formula integral a to c f of x dx is equal to integral a to b f of x dx plus integral b to c f of x dx. So like that we splitted the term. So you can say here 2 alpha, that is equal to 2 alpha f dash of alpha. 2 alpha f dash of alpha means here alpha square, because f dash x square is there. Here we thought f dash x is equal to x square we got. Here you can write 2 alpha f of alpha square plus 2 beta f of beta square, that is equal to 2 taken common, then you can write alpha into f of alpha square plus beta into f of beta square, that is option 4. Option 4 is correct answer for 11th question. Next, let us discuss about 12th question. F is continuous on closed interval a comma b. F is continuous on closed interval a comma b and differentiable in open interval a comma b. AB greater than 0, then there exists small c belongs to open interval a comma b. So by reading the question you should understand that the function is differentiable and continuous. So where it is applicable, Rolle's theorem or Lagrange's mean value theorem. In level 3, directly he will not ask, because they are multi-conceptual questions. So you should try to understand by reading the question. F is continuous on closed interval a comma b and differentiable on open interval a comma b. AB greater than 0, then there exists C belongs to open interval a comma b such that f of b minus f of a by 1 by b minus 1 by b. Given f of b minus f of a by 1 by b minus 1 by a. F of b minus f of a by 1 by b minus 1 by a. So it is in reciprocal mode. Let capital F of x is equal to f of 1 by x, you take f of 1 by x. That implies we can say f dash x is equal to f dash of minus 1 by x into minus 1 by x square. Okay, f dash of 1 by x into 1 by x derivative minus 1 by x square. Now you can substitute here. You can write f of 1 by b minus 1 by a by 1 by b minus 1 by a. That implies f dash of, according to option, f dash of 1 by x, f dash of, you can write here f dash of 1 by x into minus 1 by x square. Minus 1 by x square is equal to f of 1 by b minus, by taking LCM we may get the value, this is f dash x we write. So simply you write f dash x, f dash of small f dash of 1 by x. Verification of option we can put. If we put 1 by x is equal to c, how many options are there? With minus 2 options are there. So with square, single option. So it is first option. Now no need to calculate all the things. F of b becomes reciprocal. It should be given in the model of f of b minus f of a. So reciprocal can be converted like this. Put, I am writing, put 1 by x is equal to c. For option I am saying 1 by x equal to c minus c square into f dash of c, that's all. This is the f dash x. Option 1 here. Minus c square into f dash is equal to f dash of x. Here option 1. Next 13th question. Before discussing 13th question, some concept is there. The concept is that points of intersection of the curve. 13th question concept. Number of points of intersection. Number of points of intersection of a curve is equal to points of intersection. Points of intersection with x-axis, I am writing. With x-axis. Next one, number of turns is equal to n minus 1 with x-axis. The turns are point of intersection. Let us discuss about, let us consider example y is equal to x square. It is a quadratic equation. It is a parabola. Only one point here. What is the degree here? Degree 2. Degree 2. Number of terms only one term. Next, y is equal to x cube minus 6x square like that. Plus 6 like that. So y dash dy by dx is equal to 3x square minus 12x equal to 0 like that. How many values should be there? 3x square, x taken common, 3x taken common, you may get here x minus 4 equal to 0. X equal to 0 and x equal to 4. So the curve, cubic curve, may be like this. This is rough diagram. How many, at what value? At 2 values it is touching. Whenever, only 2, like that. If the curve touches x-axis, how many points of intersection with x-axis is the number of points of intersection. So depends upon this concept. Turns, if the degree is 3, the turns are 2. If degree is 4, turns are 3, like this. The x-axis, turn means the curve touching at x-axis. Whenever the curve touching at x-axis, then points of intersection forms. Regarding this one, 13th question, we should discuss about this concept. So 13th question now, if f of x continuous, f of x is continuous and differentiable on R, and its derivative vanishes 2 values of x, then f of x cannot vanish for more than f of x derivative of f of x vanish for 2 values. So critical points 2 values. So critical points. So whenever f dash x is equal to 0, there you make it critical points. Critical points equal to 2. Therefore, more than 3 will not be. More than 3 points or more than 3 terms will not possible. That's all. Whenever the derivative vanishes, you get the term like this. So there is no, this is the first term, this is second term. So there is no chance of third term. So more than 3 is not possible. That's all. Next, 14th one. F of x equal to x square minus cube root of mod x. F of x is equal to x square minus cube root of mod x. X square minus cube root of mod x. F of x is equal to x square minus cube root of mod x. So you should try to understand that cube root mod x is given. We know that simply I am writing, so many times we discussed that mod x is not differentiable. Mod x is not differentiable. Not differentiable at mod x is not differentiable yet x is equal to 0, because the mod x curve has a sharp corner at 0. So directly you can write the option mod x depends upon mod x. Mod x is not differentiable given in minus 1 comma 1. Option 3 you write. Option 3, because x0 belongs to minus 1 comma 1. So whenever minus 1 comma 1 is there, in the between My 0 should be exist, 0 exists there, 0 here at 0 mod x is not differentiable. That is why here the function is not differentiable. Students, we have completed 13 questions. Let us discuss 14 to 22nd in next class. Okay.